welcome students. This will mark the first section of our vacation online class, and we're going to continue with what we did when we were in school. So our last topic was on computer motherboard, and we're going to continue from here. Now when we talk about the motherboard, now we are saying that the motherboard is an essential piece of hardware, where it is often referred to as the heart of a computer. So that is what we usually refer a motherboard to, being the heart of a computer, which means without the motherboard, the computer can't function or it cannot work. And we know that it is a large, sometimes it's large, other times too it's small circuit board that houses and connects all the key components, enabling them to work together. So this motherboard that we are talking about here, in fact, it contains almost all the key components of a computer that enable the computer to work properly. So these components, the motherboard connects all of them, it links all of them together so that they work as a single unit. So that is the motherboard. And when we are talking about motherboard, we have some factors that which specifies 8 dimension, 8 power supply compatibility, 8 mounting holes and location, and the number of arrangement of ports at the back of the panel. So when we are talking about this form factor, we know that not all computers have the same sizes, so as the motherboard that lies within. So when we are talking about form factor, then we are talking about one, the dimension, like the size of the motherboard, the power supply compatibility. Not all the motherboards will have the same power supply compatibility. So different dimensions or different motherboard will have different power supply compatibility. Then the mounting holes also and their locations also matters when we're talking about a form factor, and number of ports even at the back of the panel. So now we're going to look at how the motherboard is. So this is a typical example of a motherboard. You can see that this one is a bit larger and this one is also a bit bigger than this one. So that is what we are talking about, the form factor. So when we talk about the dimension, we are talking about the sizes. So you can see that this motherboard is bigger than what we have here, and this one too is bigger than what we have here. And we're also talking about the number of ports or number of holes that we can put in different components or devices. So we can see that this motherboard is having a lot of PCIs on it, which is more than what we have on this one. This one is also having a quite number of PCIs as compared to this one too. And I think we were also talking about the holes, the number of ports at the back of the panel. And when we talk about number of ports, you can look at this one. We have a lot of ports at the back here. But when you look at this one, it will have only few. It will have only few of the ports. And even checking on this one too is very small or very few. So that is the form factor that we're talking about. Now let's move on with the main functions of the motherboard. What does the motherboard do? And why do we have it in the system unit? Now the motherboard holds and connects all the essential components. Yes, so there are some essential components on the motherboard, and the motherboard connects all of them together so that they can function as a single unit. And two, it also allows the components to work together. So this motherboard helps or allows all the components to work together as a single unit. Alright, it also provides communication pathways. These are the communication pathways that I'm talking about. Now on every motherboard, you see that we have some lines on the motherboard. Those are what we call the pathways. So if we look on this board, you can see we have these pathways on it, of which signals travels through them. So the motherboard provides the communication pathways for other components to communicate. Then on the fourth one, the motherboard distributes power to components. It distributes power to all the components that we have on the motherboard. Then 5, the motherboard also enables component upgradability. It enables component upgradability. So when you look at this one, let's go back to the motherboard. Now you can see that this is a RAM slot. So you can put RAM here, one RAM here, and because of it enabling component upgrade, you can put more RAMs on this one. So you can see that this specific motherboard has a RAM slot of 1, 2, 3, 4, 5, and 6. So that is that. Alright, let's move on. Now let's remember that the motherboard connects all components and allows them to communicate with each other, making it the foundation of any computer. So without the motherboard, these components that we're going to look at will never work together as a single unit. Alright, let's move on. Now, the motherboard form factor, I think we've talked about that one already. When we talk about the dimensions, we are talking about the physical size of the motherboard, which determines what the computer case will fit into. Alright. Then we're also talking about power supply type, specifies the type of power connectors and power requirements for the motherboard. Then we also talk about the mounting holes. Now, the standard location where the motherboard touches to the computer case. Then finally, we have the port layout. That's the arrangement and the number of ports available on the back panel for connecting devices. So these are the form factors that we talked about earlier. Let's look at this one. So we're going to look at some important components found on the motherboard. We're going to look at them. And one, we have the CPU sockets, of which I'll take you through. We also have the CPU socket holds the processor, and we also have expansion slots, or usually referred to as PCIs. Then we also have the cooling system, which regulates temperature. We have storage connectors for hard drives or for drives. We have sound card for audio processing. We have onboard components, that is, we have components that are built on the board already. We have RAM slots, we have chipsets, we have power connectors, we have IOs, then we have graphic card, and also we have BIOS and UEFI. So we're going to take these ones one by one, these components one by one, and look at how they function. Now, when we talk about the CPU socket, now the CPU is installed in the CPU socket on the motherboard. So these are the CPU socket that we're talking about here. So this is what we call CPU socket. Now a fan is usually mounted on top of the CPU in order for it to blow out heat. Okay, and we have two types of CPU sockets. One, that is the PGA, which we know it to be pin grid array, which is this one. This one, the CPU has some pins that fit into the holes that we have here. So that is why we call it pin grid array. And we also have LGA, which is the LAN grid array. This one, there are no pins, so at the surface of the CPU is very flat, of which it also fits into this socket. So these are the two main types of CPU socket that we have, the PGA and the LGA. Let's move. We also have the RAM slots. The RAM slots are where memory modules are inserted on the motherboard. RAM is a computer short-term memory where data and programs that the processor is currently using are stored. So this is what we call the RAM slots, and this is the RAM that fits into those slots. Now let's look at some specifications of RAMs. Now, RAM capacity. Now when we talk about RAMs are measured in gigabits. And with older systems, RAMs are measured in kilobytes. or even megabytes. Now, which determines how much data can be stored temporarily for quick access. Now, RAM can be used in desktops, laptops, and even smartphones. Now, let's look at the speed. Now, RAM is measured in megahertz or mega transfer per seconds. That is MT/s. Now, the RAM speed affects how quickly data can be read from and written to. The RAM speed is a high speed which generally improves performance of the computer system. Let's look at the type. Now, there are three main types that we have, but sometimes we add another one to make it four. So, we have the static RAM, of which it is short-termed SRAM, which is faster and more expensive, often used for cache memory. We also have the dynamic RAM, which is the DRAM, which are common in system memories, the main system memories, and slower than the SRAM but cheaper. We also have the synchronous dynamic RAM, which is the SDRAM, which is synchronized with the system clock for faster performance. And the last one is the double data rate, which is the SDRAM or the DDR SDRAM, which transfer data twice per clock cycle. That is, the modern system usually uses DDR4 or DDR5 for higher speed and efficiency. Let's move on. Now let's talk about the expansion slots. Now, expansion slots are the connection points on the motherboard where you can add extra components like graphic cards, SAM cards, and even the WNIC to enhance the computer's capabilities. Now, most of the times, motherboard comes with built-in components, and sometimes they are not sufficient or they are not enough for our consumption or for our use or even for the performance. Yeah, these expansion slots helps out to, I think, extend the computer's capabilities. Sometimes you may want to add extra sound, or you may want to add extra VGA to the system. So these expansion slots that we see here, these help us to add additional devices or additional components onto the motherboard for extended capabilities. So these components are the graphic cards, the sound cards, the WNICs, and others. So these ones help us to perform additional functions, and the expansion slots or the PCI ports helps us to do that. Let's move on. Let's talk about chipsets. Now, when we talk about chipsets, now chipset is often referred to as glue of the motherboard. It is basically the electronics on the motherboard that communicate with all the connected components. So all the connected components, this chipsets help them to communicate. So as we can see, we see that we have lines. These lines are leading to other components on the motherboard. So they all come together here, and this one help them to communicate together. So that is the chipset for you. So it's often referred to as glue on the motherboard, and it is basically an electronic component on the motherboard that communicates with all the connected components. All right, let's look at the BIOS. When we talk about BIOS, we are talking about the basic inputs, outputs, and system. All right, so a firmware BIOS is a firmware on the motherboard chip that runs at startup. So we have a software or a firmware which has been installed on this chip, and that firmware is what we call the BIOS. And this device that we see here, these are the BIOS chip. So it initializes hardware and run post or check hardware whenever the computer is turned on. So when you turn on the computer, this BIOS that we are seeing here will perform what we call power on self-test. It will check if CPU is working, if VGA is working, if the RAMs are connected, everything. So if the moment any of these are missing, the BIOS can report that, okay, this is missing. Unless in the case where there is no RAM, that the BIOS cannot post. And even if there is no RAM, the BIOS can also sound alarm through the buzzer, so that you know that, okay, there is problem on the motherboard, or there is problem with the system. Now, the BIOS also loads operating system from the drives. Now, it can be updated or flashed to fix or improve its performance. So that is the BIOS. Now, in the replacement of the BIOS, there is one better thing that has been replaced, and that is what we call UEFI, which is Unified Extensible Firmware Interface. This is the replacement of BIOS. Now, this is a modding, and it helps in faster boots, and sometimes has a graphical user interface that supports larger drives up to or even over 2 terabytes. It includes secure boot to prevent unauthorized OS access, and also more flexible and extensible firmware. Now, this UEFI has come to replace, or it is replacing, the BIOS. Now, the old BIOS that we have, it wasn't having user interface like the UEFI that we have, which is having graphical user interface. But with the BIOS, I think everything was in command line or something. Yeah, it wasn't having a nice interface. Let me say it this way. It wasn't having a nice interface. But with this modern one, it has an interface that even you can use mouse to select components or make changes in that interface. So that is the difference between the UEFI and the BIOS. Alright, the BIOS is an old, and the UEFI is a new replacement, which is replacing the BIOS now. But they are all installed still on the chip. That makes it work. Alright. Let's look at power connectors. When we talk about power connectors, we are saying that that all the components on the motherboard, they need power. They need power. So these power connectors connect and ensure that stable electricity is being distributed through the computer system. So this cable that we see here provide power to the motherboard through this power socket. So that is that. So power socket helps to distribute power across all components on the motherboard. Alright. So we see that it's a power supplier. Yeah. So the power connector help the power supplier to connect and distribute power across the motherboard. Let's look at the storage connectors. We also have something called storage connectors, and these are basic storage connectors. These are what we call SATA. This is a SATA storage connector. So these connectors let you attach hard drives and SSD to store all your files and programs. Storage connectors allow the computer to read and write data to and from storage devices, enabling you to save and access files, programs, and other operating systems. So these power connectors help us to access information from the hard drives that we have here. Okay. Let's look at input and output ports. Now, the input and the output ports are like the computer's communication points. They include the USB ports, the audio ports, the Ethernet ports, and many more. These allow connection of various devices and peripherals. So these ports that we have here also have an important role to play, and this helps us to connect peripheral components to them. So we can see that we have the USB here, of which it can help us to attach pen drives, keyboard, mouse, and other things. And we also have the HDMI cable here, which helps us to extend display to external monitors and others. We can also talk about the video composite and the audio composite port we have here. This gives video out and also audio out, the same way that we have this one as a video. And this is also a VGA, which also help us to extend video signals to external monitors, so as the Ethernet ports that we have here. So all these ports, all these input and output ports that we have here serve as a communication point that allows external devices or peripheral components to communicate with the system unit or with the computer itself. So we're going to talk about sound card. Now, sound card is an important component on the motherboard, and a sound card is a hardware connected to the motherboard and is responsible for handling sound received via microphone and for producing sound on a computer that can be heard through the speakers. So this card that we have here can help us to record sound onto the computer and also help us to hear through speakers, hear sound that is being played from the computer through speakers. Now, these cards that we have here, they mostly have what we call processors, and their processors are sometimes called digital signal processors. They are the digital signal processors. Many sound cards have their own processors which handles audio-related tasks, relieving the load on the CPU main processors. So this card that we have here, it processes sound on its own, so it doesn't rely on the main CPU on the motherboard to process sound, but it has its own processor, which is called DSP, digital signal processors, which converts sound for us to hear. All right, so let's move on. So these are other types of sound cards, so you can see their processors on it, the DSP on it. So we have the graphic cards. Now the graphic card is an add-in circuit board to the motherboard. Its main component is the GPU, or the graphic processing unit, which is responsible for 3D graphic rendering and displaying images, videos, and animations on the computer monitor. So this graphic card that we're talking about here helps in processing 3D images or graphics rendering and displaying images, videos, and animations on the computer monitor. Sometimes GPUs are integrated or embedded on the motherboard or built into the CPU, and some GPUs have their own memories to store graphical data separately. So these GPUs that we're talking about, they are found on the graphic card, and it helps to process images or render images and display them through the monitors. So these are examples of graphic cards, or yeah, these are examples of graphic cards. So you can see that this has HDMI and it's also having a DVI. This one is also having different ports altogether. So that is a graphic card for sure. Let's look at onboard or integrated components. Now, when we look on the motherboard, we have components that are already placed on the motherboard, and some of these components are, we have the sound chips, we have the GPUs, or we have the Wi-Fi chips. That saves user from installing separate expansion cards for these functions. Now, most of the motherboards, they come with sound, they come with video cards, they come with Wi-Fi chips and others, which are already embedded on the motherboard. So instead of installing any of these or adding these to the motherboard, they have them already on the motherboard. So there is no need for you to go for external GPUs or DSPs to be installed on the motherboard again. Unless in the case where you want to extend your performance, that you can go in for those components. But with this motherboard, everything is already built on the motherboard, so there is no need for any external component to be attached. So these are some of the things that are already on the board, so you don't need to go for external ones. We have the sound chip, we have the GPU or the GPUs, and also we have the Wi-Fi chips, which will save you from buying or installing separate expansion cards for these functions. Now let's talk about the cooling systems, of which will be the last section or the last part for this section. Now, motherboards need to cool the chips that would otherwise get too hot and degrade. Now, components, some chips on the motherboard, in fact, they really heat. They really bring up more heat. And when we get cooling system, this cooling system will just bring down those heats so that they will not burn out or they will not degrade. Now, there are two main options to safely mitigate heat from motherboard components, such as the CPU. Now, in fact, the CPU is one of the components on the motherboard which generates a lot of heat. It's one of the components on the motherboard which generates a lot of heat. Therefore, it needs to be cooled down. So we have two main options that we can help motherboard to blow out heat from the CPU. So we have air cooling, of which we use a fan and a heatsink. So, and we also have the liquid cooling. Now, a fan cooling is a method using a circulated air, and also fans move air over the heatsink. With a fan in the heatsink, the fan is usually installed on the heatsink, and the heatsink is installed on the CPU. So the fan blows out heat through the heatsink to cool down the processor under the heatsink. We also have the liquid cooling. This is an alternative cooling method that uses liquid to dissipate heat. Now with this one, it uses a liquid to cool down the CPU. Now, liquid cooling system can be more efficient at removing heat from components than the air cooling system. Yeah, that is true. So these are the images showing us how these ones works. So now this is how the cooling system works. Now this one is the fan and the heatsink. So the fan is always on the heatsink, and the heatsink is placed on the CPU. So the fan here blows out the heat the CPU will absorb, the heatsink will absorb. So the fan here will blow out the heat the heatsink will absorb from the CPU. Yeah, so that is how it works. And when we look at this, is the liquid cooling system, and this one is an advanced cooling system. Now this is how it works. Now you see that this container that we have in here stores a cold water. So the cold water will be pumped through this tube and to come to the motherboard. So when it heats, or when it gets heated, now it will be transferred to the second tube here, and the tube will transfer the water to the cooling system we have here. So it will cool down the hot water, and then it will send it back through this one, and it will come and it will be stored within here. So when there's this one is a circulating something, the hot water moves from here and it is being cooled down here, then it comes back to this container, and this container will just pump it the cold water here again, and it will come here again and cool down the system. When it gets heated, the hot water will be transferred through this tube, comes here, and it will be cooled down, and it will be sent back to this one again. So that is how the cooling system, the liquid cooling system works. I think I've spoken a lot, and I'll end here so that if you have any question, you can ask and we deliberate on that. Thank you for your time, and thank you for being with us.